everyone, I'm teacher Mandy. Today we're going to look at Booklet B from the P5 RGPS SA2 paper. Question 29. The diagrams below show the human and plant reproductive systems. At one look, we know these are both the male parts. Question. In the diagram above, mark an X on the human reproductive system that has the similar function as part Y of the plant reproductive system. Step 1. Identify Y. It is the enter. So for something that has a similar function in the human, actually the male reproductive system would be the testis. Where is the testis? It's over here and marked with an X. So being able to identify that it is the testis gets you half mark. Being able to identify it from the diagram gives you another half mark. In total, it is 1 mark. Question. Name and state the function of the organ in A. So firstly, we already know that it's called the testis. That is a half mark. The function is to produce sperms. Another half mark. In total, 1 mark. Next. The diagrams below show the reproductive system of 2 females whose ovary or ovaries were removed. Now, we do know that each female would have 2 ovaries when they are born. Now, let's look at the diagrams here. So in female A, she has 1 ovary left, and in female B, both ovaries are not present. Question. Which one of the above females, A or B, would still be able to reproduce naturally? Give a reason for your answer. So we know that the ovary is the one that produces and releases the egg. So it would be female A, reason being that she still has 1 ovary to produce and release the egg so that the sperm can fuse with it for natural reproduction. So half mark for A, and 1 ovary to produce, release an egg, fuse with a sperm. This is the other half mark. Half plus half, in total, 1 mark. Now you may find that it seems to be quite a long answer, but the part about fusing with a sperm is like a backup answer. As in, when you write it in this way, this is a very complete statement. The teacher has no reason to deduct any mark from you. So that's what we want in the exam, to get the complete 1 mark. Question 30. The diagram below shows a flower. In the diagram above, label and name the part of the flower that will develop into a fruit. So by being able to labeling it is half mark, and being able to name it is another half mark. In total, 1 mark. So looking back at the diagram in the middle, okay, we know that it is the ovary. So I'm going to point to this. Okay, that's where my half mark is. I'm labeling it and writing out the name ovary. This is another half mark. Altogether, 1 mark. Next question. Name the part of the flower that will develop into a seed. So again, being able to identify, okay, is half mark. Naming it, making sure the spelling is correct, is another half mark. In total, 1 mark. The answer is ovules. Next, Peter wanted to find out the conditions that seeds need to germinate. So again, when we think about germination, conditions needed for it, it is to do with WOW. Going back to the question, let's look at it. He prepared 4 setups, A, B, C, and D, using identical seeds and exposed them to the conditions shown below. So we have a table below. Now, question, in which setup, A, B, C, or D, would the seeds germinate after a week? Explain your answer. So we're looking out for 3 conditions that are needed for germination. WOW. What does it mean? Water, oxygen, and warmth. Now look back at the table below. Do we need light to be present? During germination, nope. So we're going to cross this out. We don't even need to look at it. Now, let's look at it one by one to decide which setup will have seeds germinating. So let's look at setup A, 5 seeds. No water. Nope, it will die. Let's look at B. 5 seeds, 20 ml of water. Okay, 30 degrees Celsius. Yes. No oxygen though. Nope, it will suffocate. It's not going to live. C. 5 seeds, 20 ml, 100 degrees Celsius. It's going to be boiled alive. So C is out too. D. 5 seeds, 20 ml, 30 degrees Celsius, and we have oxygen. It's present. Perfect. This is the one. Okay, so being able to identifying, okay, half mark, like what we have just done with A, B, C, and D using the elimination method, and explaining it, okay, what are the reasons for it? Because there is water, oxygen, and warmth, another half mark. How to write it? Over here. So half mark for D, it has water, oxygen, and warmth, another half mark. Altogether, 1 mark. Next, the diagram below shows the stages of growth of a bean plant. Question: draw a line in the graph below to show the relationship between the mass of the seed leaves and the height of the seedling during germination. Now let me use a real-life example to illustrate this. Hi everyone, I'm teacher Mandy. Today I'm going to explain a very common question about germination. So I have a pot over here, it is my succulent. When you want to grow a new succulent plant, you can just use its leaves. In the first one, okay, you see that this is a very young seedling and its seed leaves still have a lot of food for it. If you look at the second one, alright, this has grown bigger and taller. However, look at its seed leaf. It is very dried up, shriveled, and very little food left. If you were to look at the third one, which is over here, it is the tallest one so far, and it is growing very well. But you will also realize that its seed leaf, okay, is already gone by 10 to 20%. Even this part is black. However, it still has some food left for the growing plant. So over here, we can conclude that, alright, the bigger the seedling, the lesser the mass of the seed leaf. Now, from the video, as you can see, as the height of the plant is increasing because it is growing taller every day, the mass of the seed leaves would decrease because it is giving it food to grow. So of course, it will get thinner and thinner, and that will contribute to the loss of weight of the seed leaves. So the mass is actually lesser and lesser. Okay, so that's why the graph looks like this. Now, how do we get the 1 mark? So half a mark for identifying that the mass of the seed leaves will decrease while the height increases. The other half mark being able to draw the graph as shown. So in total, 1 mark. Next, question 31. Chloe carried out an experiment as shown below. Beakers A, B, and C were left near the window for a week. So let's look at the diagram here. So we have the same amount of oil in all 3 beakers, the same amount of water in all 3 beakers. So what's the difference? Beaker A, no plant. In beaker B and C, they have the same plant with the same number of leaves. But if you look down to the bottom, you see a difference in the amount of roots. There are more roots in beaker B, which means there will be more roots to take in water for the plant. Now, do take note about the layer of oil. It is quite important in this question. Let's look back at the question first. Chloe recorded the volume of water in each beaker on day 1 and day 7 in the table below. Let's check it out. In beaker A, volume of water on day 1 is 800 ml, and after 7 days, still 800 ml. Why? Shouldn't water be evaporating? It is due to the layer of oil. Whenever you see a question that has a layer of oil on top of the water, it's always to prevent evaporation. They do not want the water to be evaporated off. This is to show that if there is water that is missing after like 7 days, it has to be due to something. Okay, so it is to prove something, to prove your point. Now, let's look back at beaker B. Day 1, 800 ml. Day 7, 550 ml left. Makes sense because it has absorbed some water for the plant. beaker C, 800 ml on day 1. On day 7, 650 ml left. Yes, it makes sense as well. But you do notice that between B and C, okay, there is this more or less going on, right? We can predict questions already. Okay, let's look at what question they have for us. Question. Compare the change in the volume of water between beakers B and C over 7 days and explain the difference in the results. That's where it comes in. Okay, so compare the change in the volume between beakers B and C. So we're going to look at it here, okay, and tell us why. So when we are comparing, we are telling the teachers one of 3 things. First one, is it the same like as before? Before 7 days, after 7 days? Or is there more? Is there less? Which one? Okay, and then why is it like that? So how do you write the answer? Okay, we already know that there is more water left in beaker C, right? Which means more water is used up for beaker B. Reason, there are more roots to absorb for the plant in beaker B. Now, what is the mark allocation like? All right, so the volume of water decreased more in beaker B than C. Why? More roots to absorb more water for the plant. Now, it is a 2-mark question, all right? To be able to find out why and the more or less, okay, deciphering the data, interpreting the data, you get 1 mark. Writing it out, decrease more in beaker B than C, half mark. Why? More roots to absorb, another half mark. That's how you get 2 marks. The first step has to be there, okay? If your first step is not there, you can't even get the 1 mark, then everything will be wrong. That's why this part about interpreting the data gives you 1 mark out of 2. Question. Explain the purpose of beaker A. Now, beaker A is actually used as a control setup. Again, all right, is to prove a point whenever you have a control setup. So what is it trying to prove? Okay, so control setup, it goes to show that if there is no decrease in the amount of water in A, then, okay, the decrease in the volume of water in B and C are only due to the roots absorbing the water for the plant. So half mark over here, all right, and half mark over here. The phrasing is important. Okay, total 1 mark. Next, question 32. The diagram below shows the percentage of undigested food substance A in different organs in the human digestive system after a meal. So undigested food is the keyword here. So let's look at the graph. Okay, the mouth, all right, percentage of undigested food, okay, it dropped. Yes, because there is saliva. It will digest some of the food. In organ X, no change. It's the same because it is the gullet. In the gullet, no digestion takes place. It's just a movement of food from the mouth down the gullet to the next organ, which is organ Y, the stomach. But how do I know it's the stomach? Now, there is some digestion taking place in the stomach because there is digestive juices. So you'll see that the amount of undigested food has dropped again. And I can further confirm that organ Z is actually small intestine. Why? There is a highest amount of digestive juices in small intestine. And because of that, a lot more food is digested in the small intestine. So the percentage left will be very little, resulting in a very sharp drop, as you can see in the graph over here. Question, identify organs X and Y. Okay, so they are the gullet and the small intestine. Half mark, total 1 mark. Question, name the part of the digestive system that produces digestive juices. So it's a 1 mark question, but we have 3 parts to the answer. So how is it allocated, right? How is the mark allocated here? Now, if you just give 2 out of 3 answers, it is incomplete. We are only going to give you half mark. But if you're able to give me all three, then you get the full 1 mark. All right, a bit tough life, I understand, okay? But because you have already figured out what is going on in the graph over here, question B is actually a giveaway mark. All right, so the main thing is always to identify what is in the graph, what is in the table, or what is going on, and you get the mark very easily. Next one, C. Explain clearly why the percentage of undigested food substance A decreased the greatest in organ Z. Now, organ Z is the small intestine. So this is something to do with the background information you have studied for the exams. Then you apply it in this question. So in the exam, there are a lot of such application questions in Booklet B. We have them in Booklet A too, but much more in Booklet B. Okay, so you have to study the information, which is just the basic. Applying it is really the key here. Okay, so how do we write it? So organ Z produces the highest amount of digestive juices. So rate of digestion is the highest. Thus, more food will be digested in organ Z. Half mark over here and half mark over here. In total, 1 mark. Next, question 33. The diagram below shows how digested food and gases are transported in the human body. So we have three systems, system P, Q, and R, and we have some helping words here. So when they talk about air going through system P, and after that it becomes exhaled air, we know it is talking about respiratory system. Next, food going through system R. If it's a food system, it is the digestive system. Okay, I put DIG for short. Now, in the middle, we have system Q, which works together with respiratory system and the digestive system. The one that you have learned in school that works together with these two systems are the circulatory system. All right, so now that we have identified all of them, okay, it becomes easy. Identify system P. We got it. All right, now 1 mark. How does 1 mark come about? All right, so half a mark, okay, for identifying it over here. The other half mark for spelling it correctly. So make sure your spelling is good. Next, name 2 gases which will increase in quantity in the exhaled air as compared to the inhaled air. Okay, now we all know that when we inhale more oxygen to be absorbed into the lungs. The one that we do not want is something that we give out, and it's in the exhaled air, that is carbon dioxide. The other one is something that students usually miss out, okay? It's actually water vapor. But why do students tend to miss out water vapor? Because of the word water. You see, humans are very quick to judge certain things sometimes, right? So the moment you think of water vapor, you only hear the word water. That's the problem, okay? Vapor is gas itself. So water vapor is water in the gaseous state. Always remember that, okay? So the answer is water vapor and carbon dioxide. Half a mark for this, half a mark for this, total 1 mark. Next, explain how systems Q and R work together to ensure that cells in the other parts of the body receive water. So going back to the diagram that we have, okay, system Q is the circulatory system, system R is the digestive system. Okay, so water would first be in the digestive system, but which part in the digestive system? You have to mention that. Then, okay, talk about the circulatory system. So we know that water is absorbed or removed in the large intestine. We have to mention this, half mark. And then it will enter the bloodstream to be transported to all parts of the body, the other half mark. So that's how system Q and R work together. So over here, half mark. And over here, half mark. In total, 1 mark. Done. Next, question 34. The diagram below shows the human respiratory system and part of a leaf. Okay, so in the human respiratory system diagram, they focus on part X. This is actually the air sacs. Okay, we have to identify, remember? In leaf, okay, the tiny openings on leaf surface is actually the stomata. That's how it looks like. under the microscope. Question. State one common function between structure X and Y. So we already identified what is X and Y. What they do, they help us to breathe. They help the plant to breathe. But it's best to use the word respiration or gaseous exchange. So allow gaseous exchange. Being able to identify the parts is actually half mark. So identifying that it is the SX and the stomata is half mark. Knowing the function is the other half mark. In total, 1 mark. There are 2 parts to it. Next. The surfaces of the leaves of a plant were coated with a layer of oil. 1 week later, the plant died. Explain why the plant died. Okay, so in this question, okay, it's just going to look at the leaves and then it is coated with oil. It's blocking the stomata. Can it respire? No. Okay, so for figuring this out, 1 mark. For writing it out is the other 1 mark. Okay, so how do you write it? Okay, the layer of oil blocked the stomata, half mark, and prevented gaseous exchange, the other half mark. All right, with no respiration, the plant died. Okay, now half mark over here is being written out 1 mark. The other 1 mark, okay, is about figuring out the part. Total 2 marks. Okay, done. Question 35. The diagram below shows a plant. Okay, so again, let's identify what is X. Okay, it is actually the root because it's in the ground, in the soil. Okay, now question, which part of the plant does X represent? It's the root. Okay, so for identifying it over here, half mark. Writing out it on with the correct spelling, another half mark. In total, 1 mark. Next, question, what is transported to part X to be stored? Okay, so they will make the food in the leaves, then it will be transported down to the root to be stored. So figuring this out, half mark. Writing it out, food, half mark. In total, 1 mark. Sorry about that. Okay, done. Next. The diagram below shows another plant, so a totally new scenario. So we have a diagram here. There is a flower with the soil. Now draw arrows in the diagram above to show how water is transported to the flower on this plant. So we know the function of roots, okay, is to absorb water for the plant. Then it will be transported up the stem to the flower. So we just have to draw the arrows, okay? Now, if you draw the arrows like here, you're not going to get the answer because it's not in the roots, right? So this part is no. Okay, so this is a no-no. I'm just going to cancel like this. So we have to draw the arrows inside. So up the roots, absorbed by the roots inside it. Go up because it doesn't stop there. It's going to reach the flower, remember? So it's going up and up to the flower with another flower here. So 2. Okay, now in the exam, they will give you a bigger diagram, okay, or a thicker stem because you will be, you need a space to draw it so it's clear. All right, it would be good to use a blue pen for this. Okay, in the exam, usually we will encourage students to use blue or black pen. Even for diagrams drawing, okay, because it's science, it's not math, okay, it's science, we will encourage you to use pen for the answer. All right, if you're worried that you will get it wrong, very simple, use a pencil to do a draft, sketch it out first. Then once you're very confirmed that that is the answer, then draw over it with dark ink, like dark blue or blue ink or blue pen or black pen. You get the idea. Okay, and draw it big and clear. If it's too small and too tiny, the teacher cannot see what is going on, you're not going to get a mark. Okay, so half a mark, okay, for knowing the functions of the roots and the stem because the water is traveling up. The other half mark would be you drawing the arrows. In total, 1 mark. This is a very commonly tested question. Okay, so question 36. Peter carried out an experiment by cutting and removing two rings X and Y of different thickness from the stem of a plant as shown below. So we see that we have, let's look at it from the bottom up. It's easier. So from the bottom, we have the stem, and then only food carrying tubes have been removed. Okay, so no food. And then we have leaf A, okay, but can it still get water? Yes, yes. So I'm going to put down has water. All right, it's just no food. Okay, and then go further up over here at X, both water and food tubes have been removed. Okay, and then we have leaf B over here. Leaf B has nothing. No food, no water. It's probably going to die very soon. Okay, now question. Let's move a little up. The stem shown above was then placed in a beaker of red colored water. He observed the color of leaves A and B, recorded his observation in the table below. So what happens after? Based on the information above, put a tick in the correct boxes indicating the color of leaves A and B after 1 day. Okay, after 24 hours. So the water will be transported up the stem. Okay, it can still go up over here, right? Because it still has water carrying tubes. So it will reach leaf A. So leaf A will turn red. How about leaf B? It has nothing, remember? Everything is removed. So green. There's no water for it. Sad guy. Okay, anyway, half mark over here, the other half mark over here. And done. Next. So it's the same diagram, but they are asking a new question. After a week, the stem at W swelled as shown in the diagram below. So question, explain why plant W swell up after a week. Now, for those who don't know swell, why swelling is expanded, but we don't call it expanding because expanding is more used for magnets and materials, right? Okay, swelling is more for like living things. Like if someone punches you, you're gonna have a swelling here. Okay, so same thing for the plant, but it's not being punched here. Let's find out what's going on. So let's look at it from the stem going up again. Okay, the water, the food. Okay, but the thing is here, food carrying tubes have been removed, right? Okay, so leaf A, I'm gonna make the same notes, has water again. Okay, and then they never show leaf B. Okay, so I'm just gonna write this. Then X is all the tubes are removed. Okay, so let's see what's going on. Okay, so we have water moving up, being transported to the leaf. Okay, so it has water, it has light, it has carbon dioxide, it can photosynthesize, so it can make food. Okay, now after it makes food, the food is not stored in the leaves. Where does the food go? It will get transported to all parts of the plant, right? So of course it will keep moving up. It will also be moving downwards to the roots, to the stem. However, because the food carrying tubes have been removed over here, can the food move down the tube? Totally no. So after 1 week, so it makes a lot of food accumulating day after day. The food is all stuck here at W. So of course it's going to swell up because the food is all stuck there. It's accumulated. Okay. So how do you write the answer? Food can still be made in leaf A, but it was not transported down, okay, as the food carrying tubes were removed at Y. Food was accumulated, so W swell up. Okay, now, how is the mark allocation given? All right, now, being able to identify this part, okay, the part about making food being swell up, okay, this part is about half mark to 1 mark, depending on how you look at it. Okay, because in the answer we have to write quite a lot. So different teachers might have different mark allocation for this. This is a little subjective. It's not 100% thing. Now, food can still be made at leaf A, another half mark. Not transported down because the tubes were removed, another half mark. Accumulation of food, so it swelled up, another half mark. So Half mark over here, half mark over here, half mark over here, half mark over here. In total, 2 marks. Done. Next, question 37. Rani's living room and kitchen are separated by a glass door as shown in the diagram below. So they have a glass door. Okay, some of us have it, okay, so that the smoke and the fumes and everything don't go into the living room. Now, Rani was in the living room with an air conditioning turned on at 18 degrees Celsius. Wow, good life. While her mother was in the enclosed kitchen, so it's closed up, cooking a meal. All right, so once you're cooking, it gets a little warm, right? So the temperature in the kitchen was 36 degrees Celsius and the glass door was completely closed. So again, she's telling us that it's enclosed, it's tight, okay? So we do see quite a huge difference in temperature. 18 degrees Celsius in living room, 36 degrees Celsius in the kitchen. All right. After 30 minutes, Rani saw that there were water droplets on the glass door. In the diagram above, draw the water droplets on the correct part of the glass door. Okay. It would be over here on this part. Then you're like wondering why? Why not on the other side? Okay. Now, when the kitchen is in 36 degrees Celsius, what will happen to the surrounding air? They will have a similar temperature. So it will be warmer water vapor. That is for sure. Okay, because the surrounding air is so warm, that's why you feel warm if you're in the kitchen, right? On the other end, the living room, it will just be 18 degrees Celsius. It's cooler, okay? And because of that, it will cool down the glass door. And the glass door, if you're going to touch it, is it going to be hot or cold? It's going to be cooling, right? Okay, so condensation has taken place. Okay, now condensation requires a cooler surface and warmer water vapor. So we figure out these two parts. Cooler surface is the glass door, warmer water vapor is from the kitchen. And that's where we get our mark. Figuring the whole thing out, half mark. Drawing the water droplets, another half mark. In total, 1 mark. Done. Okay. Next, they're asking you why. Okay, explain your answer. Like, why is the water droplets on that side? Okay. So since we already figured it out, we just have to write it out. Okay. How do you write it? You have to talk about the higher temperature in the kitchen. There is warmer water vapor, which condenses on the cooler surface on the glass door. So you have to tell me where is the cooler surface as well, forming water droplets. Okay, where do you get 2 marks? Half mark for higher temperature, half mark about warmer water vapor, condense on the cool surface. Okay, but the cooler surface is on the door, another half mark here. Altogether is 2 marks. Done. It's a long thing, right? But once you figure it out, it's easy. Okay, that's why it's A part 1 and A part 2. They are related. Next question. Okay, this one was a bit blocked already. Then, okay, I'm going to just, yeah. Okay, then Rani's mother stopped cooking. Yes, I think she finished cooking her lunch. So after an hour, the temperature in the kitchen was 25 degrees Celsius. So it's not so warm anymore. It was observed that there were less water droplets formed on the glass door. Explain why. So we already know condensation took place. Now they're asking you why lesser water droplets? Why lesser condensation? Okay, so the difference here is 25 degrees Celsius versus the 36 degrees Celsius when she was cooking. All right, now, is the temperature difference lesser now? Okay, if you think about it, all right, 25 degrees Celsius is not so warm anymore compared to 36. However, in the living room, it's still 18 degrees Celsius. You get it right? Now, there will still be condensation because we still have a warmer water vapor in the kitchen and the cooler surface of the door due to the living room temperature. It's just that, okay, the condensation is lesser. There is lesser water droplets because we are comparing between 36 degrees Celsius when it was cooking hot with 25 degrees Celsius. Then the next thing you're asking is, God, how do I write this? Let me help you. Okay. So temperature difference between the kitchen and living room has decreased. So the rate of condensation is lower, resulting in less water droplets being formed. Where do you get the 1 mark? So you have to tell me, sorry, I forgot this one. Temperature difference has decreased. Rate of condensation is slower. Altogether, 1 mark. It's a lot to write, I know, but you get the full 1 mark. It has to be a complete answer. Tough life, I know. Okay, after eating, they're going to start washing the dishes, right? Okay, so Rani's mother washed the dishes and placed them as shown in the diagram below. So plates are being stacked up and there are also some plates on the rack. Now, which plate placed on the stack or the rack would dry faster? Explain your answer. 1 mark for this. Now, this one is about rate of evaporation already because we are looking at, water droplets disappearing, okay, not disappearing, evaporating. So we are going to look at the exposed surface area. Now, okay, look at the plates on a stack. Okay, I can only have the exposed surface area, that's the biggest one here. Then the rest are like, there's only a bit here by the corner, a bit here by the corner, and so on and so forth. Okay, I can't really get the ones, the water droplets in the middle to, evaporate off that easily. Whereas for the ones on the rack, firstly, when you place it like this, the water droplets are going to go sliding down. Right, okay, so that's like helping to evaporate faster. Then, okay, there is actually some space in between them. Okay, if I were to draw the space, it looks like this, and that is fully exposed here. So the amount of exposed surface area is so much more when it's placed on a rack. So of course, the rate of evaporation will be faster. And so the plates on the rack would dry faster. How to write it? So plates on the rack will dry faster. Larger exposed surface area, so rate of evaporation is faster. Okay, now this one, I'm going to give you some bad news. Okay, now the plates on the rack, I'm not saying they will not give you a half mark, but because you need to mention two keywords here, larger exposed surface area and rate of evaporation being faster, okay, it already equals to 1 mark. So do they give you any mark for the plates on the rack? It is similar to a question we did just now. There are 3 parts to one answer, but it's only 1 mark. So same thing, if you only tell me 2 parts out of 3, you only get half a mark. Okay, but if you can tell me all 3 parts, you get the full 1 mark. It's just that in the booklet B, we don't have 1.5 mark question. Not really. Okay, so it has to be complete answer. Sometimes life is like that. Yeah. Okay, let's move on to the next question. This one, question 38. Okay, so Ben was performing on a stage where 3 stage lights X, Y, and Z were positioned as shown in the diagram below. Okay, so X is here, Y is here, Z is here. Okay, and then you have a wooden backdrop. So we know it's opaque. And then he is standing on the stage. All right, question. If all 3 stage lights were turned on at the same time, how many shadows of Ben would be observed? This one is easy. So when the light is shining from X, okay, there'll be 1 shadow here. Shining at Y, shining from Y, okay, because humans are opaque, right? So there'll be another shadow forming here. It's shining all the way here. And then Z, okay, it will be shining all the way here. So there's like another shadow here. So in total, it will be 1, 2, and 3. 3 shadows. Okay, so done. Next one, okay. Which stage light, X, Y, or Z, will allow the shortest shadow to be cast on the wooden backdrop? Oh, sorry, give me a minute. Okay, would be cast on the wooden backdrop. Okay, so I have to remove this one. Okay, so I can see clearly, okay? So we're only talking about this part. Nothing to do with the stage, okay? So X is already out because the shadow for X will be here. I don't need this. I'm only asking about wooden backdrop here. So it boils down now to Y or Z. Which one has the shortest shadow? Okay, I'm going to go with Z first to illustrate something. So it shines here, right? And because he is quite tall, the shadow is going to be like this. Right? Okay. Then, okay, for Y, I only see like a bit of him. So the shadow is going to be like a bit here. Okay, let me try again. Okay. So if I were to just have Y, okay, the shadow would be like this only. So between Y and Z, okay, the shorter shadow would be Y, or rather the shortest one. Okay, so the answer is Y. Okay, so for figuring this out, drawing out your science working, drawing out here is half, writing the correct one is half. Okay, altogether 1 mark. Next, this one. Okay, towards the end of the performance, only stage light Z was turned on. Okay, so stage light Z, okay, so it's going to be like this. And then he's will be like that, shadow. Now, the diagram below shows the shadow cast on the wooden backdrop. Yes, obvious, it will be like this. Now, based on the diagram above, okay, based on the diagram above, state the property of the material of Ben's guitar. Okay, it has to be opaque because it can cast a shadow. Okay, so you just tell me it is either opaque or does not allow light to pass through. Okay, so the figuring out part is half mark because you know that it has to be opaque. Writing out the correct spelling of it, another half mark. Of course, in the exam, if you do not know how to spell opaque, which you should know, all right, I'm so sorry. Okay, you can write does not allow light to pass through. That's another way to survive the question. Okay, next one. Now, describe what would happen to the size of Ben's shadow as he moved nearer to the wooden backdrop of the stage. Now for this one, you don't really need to memorize, oh, so if the object move closer to the light source, is the shadow bigger or smaller, lighter or darker? Now I'm going to teach you one trick. This is something I invented. It's from me, okay, teacher Mandy only. Now, I don't memorize this. For me, when I go to the exams, okay, I'm going to use the ceiling light in the exam hall above my head, okay, and my hand. And, okay, if I'm putting my hand like this, the shadow will be cast on the table, of course, right? So if I'm moving my hand, okay, closer to the table, is the shadow bigger or smaller? I'm gonna do it this way. Okay, is the shadow darker? Is the shadow lighter? Okay, or if you want to put it in another way, okay, let's go back to the normal one. Okay, if I move the object further away from the light source, which is on top, so I'm moving further away from the light source, is the shadow bigger or smaller? So I use this to answer questions like D, size of shadow. If it moves nearer to the light source, moves further away from the light source, or move nearer to the wooden backdrop, things like that. So I don't memorize it, okay? Because if I can use tips like this, why not? And it works, right? But please don't do funny actions in the exam. The teacher will be looking at you like, what's going on? All right? Don't do things like that. It's very dangerous in the exam. They might think you're cheating or something, okay? Just do it discreetly, Okay, so what's the answer? It would be smaller, okay? Half mark for figuring out, okay? The other half mark for writing smaller. Altogether, 1 mark. And done. 39. Oh, cannot see the answer. Okay, a balloon was set up near a sharp-pointed metal rod as shown in the diagram below. Okay, so what happens after that? Then they heat it using a Bunsen burner. Okay, metal rod will get heated up. It will be expanding, So why did the balloon burst? This one is easy. Okay, since it has to do with heat, we're talking about good conductors, poor conductors. We're talking about probably about evaporation sometimes. Over here, there's no evaporation, no water. So now metal is a good conductor of heat. Yes. So when it's heated up, it will swell up. Okay, we cannot use swell, right? It will expand. And because of that, if it expands, the sharp point will burst the bubble. As simple as that. How do you write it? Metal is a good conductor of heat, so it expanded in volume and burst the bubble. Okay, now half mark for good conductor of heat, expanded in volume, half mark. In total, 1 mark. Then you're like, hey, I figured it out. You should give me like 2 marks for this. Sometimes life is like that. It's a bit weird the way they allocate the marks sometimes. Although I do agree, they should give you 1 mark for figuring out. But yeah, okay. Next one, okay. The sharp-pointed metal rod was then replaced with a sharp-pointed glass rod of identical length, identical size, and shape placed at the same distance from the balloon. So the only difference is the material here. Okay, and we understand why, because again, they're testing you on conductor of heat, expanding. Okay, now, next, what happened? The glass rod was heated again using the Bunsen burner, but the balloon did not burst. After 3 minutes, they only give it 3 minutes because they want to compare it against the metal rods 3 minutes. Question, why? Give a reason for the observation above. How come it did not burst? Why? Shouldn't it be bursting after 3 minutes? I gave it the same time, you know? Now, so again, tell me about the conductor. All right, tell me about the expanding and tell me about why it didn't burst. How to write it? Glass is a poorer conductor of heat because I'm comparing them now. Is it better? Is it lesser? Is it more? Is it less? Poorer is the word here. Poorer conductor of heat. Gain heat slower. Okay, I've talked about gaining heat. Expanded slower. So it was not able to burst the balloon in 3 minutes. Okay, now, mark allocation, half mark for telling me poorer conductor. Okay, now the part about gaining heat slower and expanding slower is in the same half mark. Yeah, okay, and then total 1 mark. I know, they should give you 2 marks for this, I know. Okay, I also feel bad for you, but sometimes it's like that, it's just weird. Okay, next one. Now they change the whole scenario. So in another experiment, a rod made of metal and glass will place over a Bunsen burner as shown in the diagram. Okay, now the temperatures of the metal and glass parts of the rod were measured at a distance away from the middle of the rod. And then they plot the result on a diagram below, which is in a graph. Okay, now we realized that one of them had a higher temperature, which is P. Okay, now between glass and metal, which one will have a higher temperature over the same time? Of course, metal, which we already know from the previous question, actually. Okay, so question, which line, P or Q, best represents the change of temperature of the metal part of the rod? Why? Again, we're comparing better conductor, poorer conductor. Why? Okay, easy, we know this. So you have to tell me it's P. Why? Metal is a better conductor, so it gains heat faster than glass and so has a higher temperature. Okay, this is nice. They give it to you for 2 marks. Okay, so for figuring it out, okay, it's going to be, I'm going to put it as 1 mark here, figuring out, because you have to interpret the graph, you have to understand the graph, right? Okay, and then telling me that is P, half mark. Okay, also writing out that is better conductor of heat, another half mark. Okay, so we will also link together the gain heat faster, okay, with this half mark with the better conductor. Altogether, 2 marks. Done. This one is a better one, right? They give you 2 marks for this. Okay, next one, 40. Okay, Kenny set up 2 electrical circuits, J and K, with light bulbs in different arrangements. So whenever you see electricity chapter, okay, and they tell you the word arrangement is always about parallel and series. There's a third way to arrange, which is a combination of the two. So it's about all this. So he added an identical light bulb to each circuit after recording the light intensity, means how bright it is or how not bright it is. He plotted the results as shown in the diagram, in the graph below. So the one that is a blank box, okay, is circuit J, the bulbs in circuit J. The ones that is shaded is the bulbs in circuit K. Now, if you look carefully at all the blank boxes, whether it's 1 bulb, 2 bulbs, or 3 bulbs, the light intensity or the brightness stays the same. Only a parallel circuit would have the same amount of brightness. And then when you look at the shaded one, which is the bulbs in circuit K, if you add more bulbs, you realize that the brightness decreases. It has to be in series. That's the properties. So it's easy, we figure it out. So circle the correct answer to show the arrangement. Circuit J, we already know that it's parallel. Circuit K, series. 1 mark, okay. Half a mark for this, half a mark for this. Okay, yes, the figuring out, they should give you another 1 mark for figuring out, but yeah. Okay, next question. This one, this one need to do a bit of work. Okay. Now, Kenny then constructed an electrical circuit using a battery and 3 identical light bulbs as shown below. So, okay, what exactly do they want to ask? He continued by telling us, Kenny observed that when one of the bulbs was fused, the other bulbs remained lit. It has to be parallel circuit, right? That's how it works. Okay, over here we see a combination, parallel and series. So question, identify the bulb that was fused. Now for questions like this, you have to use the trial and error method. How to do it? Watch carefully, okay? So I'm going to say, I'm going to try out to have A as the bulb that is fused. So I'm going to cancel it out. Okay, now since it is fused, okay, electricity will not be able to pass through A. So how will the electricity, path look like? Okay, so let me just remove this very quickly. All right, and then let's see how it's going to move through. So I'm going to have electricity moving like this. Okay, make sense? Yes. Okay. Now, so it does make sense that when one bulb fuses, the other bulbs remain lit. Okay, so I'm just going to write down that I tried A and it works. Okay, now I'm going to try B. Okay, so let me remove this again. Okay, so if let's say B is the one that is out, I'm going to cross it out and make it more obvious here. How will the path of electricity look like? So it's going to look like this. Oops. Sorry. Okay, so here is how it's going to look like. Yeah. Okay, so we double check. So one bulb fuse, A and C can still light up. Yes, it's correct. Okay, so light bulb B can also feed whatever has been, described. So let's remove this. Let's try light bulb C. Okay, so if light bulb C is the one that's been removed, okay, how will the path of the electricity look like? So it's going to look like, let's stop here. Okay, let's go by another direction. Let's try this one. But it's not a complete circuit because the other part of the battery over here is not connected because of the light bulb C. So if C is the one that is fused, A and B will never be able to light up. It's just not complete. The circuit is just not complete. So identify the bulb that was fused. Okay, your answer can be A or B. Just choose one because you are only asking for one. All right. So half mark for trying this one, another half mark for trying this one because we try out 2 scenarios, right? Try and error. In total, 1 mark. Then your question would be why? Why didn't they just ask identify the bulbs that were fused? It's trick you. Generally, it's to trick you. Sometimes there are just 2 answers like that. Okay? And done. Let's continue. Question 41. This is a simple one. Now, the diagram below shows the parts of a torch. So we have the diagram here. Okay. In the space provided, draw a circuit diagram using electrical symbols to show how the bulb, the batteries, and the switch are connected in the torch when the switch is open. Now, if you know how to draw electrical symbols, it's easy. The next thing is to figure out how many bulbs, how many batteries, how many switches. And one more thing, how are they connected? Series, parallel, which one? So look back at the diagram here. It is in series. Okay. And then according to what we have in the circuit, we can just start drawing. Okay. So I'm going to make this slightly smaller so we can see everything. Now, I want you to take note of one more thing. They give us such a big box. They are not looking for us to draw a very small diagram. Please fill up at least 70% of the space here. Make it loud, make it clear, all right, so that the teacher can see it loud and clear, big and wide, all right? So, one bulb, Okay, so there is one bulb. So I'm just going to draw one bulb. And we have two batteries here. So I'm going to put my batteries here. Okay, and then over here, the switch, one switch, is it open or closed? Open, right? Okay, so I'm just going to draw my switch. I want to make it bigger, remember? So I'm going to draw my switch here. I'm going to put it like this. Now I'm going to connect everything in a series. So always remember to take out at least 70% of the space. To double check, okay, I check, okay, I have one bulb. All right, it's correct, one bulb. I have two batteries. I have one switch here, and it's open. And it's in series, okay, it's correct. The wires are connected in series. The whole circuit is in series, done. So where are the 2 marks? Okay, firstly, okay, half mark for drawing the bulb, half mark for the batteries, half mark for the switch, half mark for the series arrangement. In total, 2 marks. Of course, knowing the symbols to draw is basic. We are expecting you to know because it is easy to know and it shouldn't be such a problem for you. So we're not giving you any mark for that. You are supposed to have studied for this. So again, application questions. Yeah. All right, let's look at the next one. Oh, too much. Okay. Edwin bought, sorry, let me just change it back to a bigger size one so it's easier for everyone to see. Okay. So, okay, this one. Edwin bought a new torch that came with 2 new batteries. He noticed that there was a paper strip between the contacts of the switch, as shown below. All the components of the torch are working. Now, when we have an electricity question and they talk about paper, it's to do with conductor already, right? Okay, so question, explain why when the paper strip was placed between the contacts, the bulb did not light up when the switch was turned on. So background knowledge, paper, insulator. It will never conduct. It's not even poor conductor, it's an insulator, totally zero conductivity for electricity, okay? And writing it out properly and correctly, the other half mark. So altogether, 1 mark, okay? How do you write it? Insulator, half mark, okay? And then figuring out the, knowing the background knowledge, another half mark. So make sure you know how to spell insulator. All right, there are certain science spelling words you have to know, have to do science spelling every week for every lesson, okay, or every chapter, not every week, every chapter. Next one. Now, he rearranged the battery, so we focus on the batteries here, okay. Now, would the bulb light up? Explain your answer. Now, this is an application question. In actual fact, it's related to life because sometimes it happens to us, right? We put in wrongly, then we realize it. So over here, okay, you do see that the ends are placed wrongly. Okay, so it's very easy. Answer is no. Explain. The batteries are connected wrongly. The ends of the battery are at the wrong ends of the torch, you know, things like that. So no, not light up. Batteries are placed wrongly. Okay. Where do you get the full mark? Okay, if you want to put it as half a mark over here for the word no, okay, we can understand. But placed wrongly is actually the main one. All right, it's more of writing it being placed wrongly and understanding whatever is being drawn here. It's more like that, actually. Understanding and interpreting the diagram correctly. Okay, is the half mark. And the other half mark is actually writing out saying that it's been placed wrongly. You get 1 mark. The part about no, it would not light up, okay, is something that you have to write in. So again, there are 3 parts to this question. If you give me 2 parts out of 3, I'm only going to give you half mark. But if you're able to give me all 3 parts, I will give you the full 1 mark. So that's how they allocate the mark. And we're done. Okay, that's the last question for this paper. All right, I hope you have learned a lot today. All right, I will continue to make videos like this for Booklet B, telling you what are the keywords, where are the marks allocated, and how to score AR1. in your science. This is what we have been doing in our science flashcards anyway. All right, so I'll see you in the next video. Bye-bye.